So we're going to be looking at maximum and minimums, extreme values, okay? We're going to take a look at this equation here. We have a cubic function. We're going to be looking for the maximum and minimum of this cubic function. The only thing is there's a restriction on it. The restriction is that it's every number between -2 and 1. So if we were to do a rough sketch of a cubic function, okay, this isn't perfect of this one, but they usually have some form like this, right? Which means they go up and down forever. So how can they have a maximum or minimum? Well, because we have a restriction on it at -2, say here, and the value of 1, let's say it's here. Okay. Because there's restrictions on this cubic function, that means that there is going to be a max and minimum value to it. Whether they occur in the middle of it, where it tends to change directions, or the end and the beginning, we have to find this values out. So we know that we're going to actually have to test the two extreme values, -2 and 1, because that's where they stop. And for all we know, the cubic function, that's the highest and lowest point in the specific one we have. But there's also going to be turning points, and it's possible that this thing has stopped something like this, where the turning points are the highest and lowest points. And if that's the case, those turning points are when we have a rate of change of what? 0. So in order to find rate of change, what do we do to a function? We derive it. So we're going to derive this function and set it equal to what values? 0, so that we can find when rate of change is 0, and we'll know what values to plug into our original equation to simplify this process. So we're going to derive our function f prime x is equal to 3x squared minus 6x. Okay. And what we're going to do is we're going to be setting this equal to 0. We'll set it equal to 0, and we can take out 3x, which will give us x, and -2. Okay. With that being said, we have two values that could be, two values of x that could be 0. We have 3x is equal to 0, and we have 0 equals x minus 2. Reason being, if either of those were to equal 0, we have an equation of 0. So when x is 0 or when x is 2, this question is, the rates of change are 0. So if the rates of change are 0 at those points, we can use 0 and 2. But let's look at our restrictions. Do both 0 and 2 fall within our restriction? No, 2 doesn't fall within. So even though it is a point on our cubic function where the rate of change is 0, because it doesn't fall within here, we're not going to test for 2. We're going to test for 0, and we're going to test for our extreme maximum and minimums. So the x values we'll be using, I've forgotten them already, -2, 0, and 1. So we're going to plug those into our original function f of x to find coordinates along this cubic function. So our original one, x cubed minus 3x squared, x cubed minus x squared. When we plug in -2, so f at -2, we get -2 cubed minus 3 times -2 squared. That's going to give us -8, 4, -12. Is that -20? Yeah? Great. Thank you for that quick confirmation. Someone follow along with the calculator to help me out, okay? So this is one of the coordinates. Let's try another one. F at 0. This one will be a little easier. What are we going to get? Anyone know? 0. Excellent. So we have a value at 0 and 0, so it's going through the origin. And finally, f at 1, which gives us 1 cubed, minus 3 times 1 cubed, which gives us the value of 1 and -2. Is that right? I think that's right. Okay. So now all we have to do is look at our coordinates and focus on their y values to find our max and our min. What's our max value here? 0 is our max value. What's our minimum value? -20. Okay, so we've now found our max and our minimum. Our max is the value of 0 and 0, and our minimum is the value of -2 and 20. All right, so our second question here is a fuel efficiency question. They've set fuel efficiency equal to the speed of a car, which is our variable v. So our efficiency is measured off of the speed of our vehicle. This is S, whatever. In liters per 100 kilometers, okay, for a car driven at the speed in kilometers per hour. If the speed limit is 100 kilometers an hour, determine the legal speed that will maximize fuel efficiency. So, we need to make our parameter from this question. Does anyone know what this gives us as a parameter?
Kilometers an hour.
We're in kilometers an hour. What are the values? What are our maximum and minimum values for this?
0 to 100.
0 to 100. Technically, it's not 0. I could drive my car backwards, right? But we go, assuming we're talking about legal, we'll say it's 0. Stop still, okay? So 0 to 100 are our values here. So X is between. And it really shouldn't stop still. I guess you could be in park. Okay, so these are our parameters where X is every number in between them. This is our efficiency. So, depending what this function looks like, with these parameters, we need to find out any rates of change of 0 also. So we're going to have to derive this function. So the derivative of this function. And I'm just going to rewrite the function down here. Just because I won't be able to memorize it. 1600v over v squared plus 6,400. Okay, so we have our function. We're going to derive this function. So, quotient rule. This will become v. Whoa, no. It becomes 1600. Come on, guys, derive. 1600 multiplied by the original on the bottom, which is v2 plus 6,400. Subtract the value of 1600v times the variable here, which is 2v. All above v squared plus 6,400 squared. Okay. Let's simplify what we have on top, or at least try to. That will give us 1,600 v squared. I'm going to need a calculator for the next one. 10,240,000. Like that. And this will give us 3,200v squared. Excellent. We'll keep the bottom as is, the denominator. I'm not going to do anything with that. V squared plus 644 squared. And on top, this becomes negative 1,600 v squared plus 10,240,000. Is that right? Okay. So, we're looking for what? Rates of change when they're equal to what values? Anyone remember? When they're equal to 0. So really all that means is we only need to focus on the top of this quotient function. Whenever the top of this is equal to 0, this will equal 0, assuming that same value doesn't cause a hole in the function or make it be undefined. Okay? So we'll have to test that, but it looks pretty unlikely from what we have done. Okay? So let's take the top part and set it specifically equal to 0. Okay? So we'll take this, set that equal to 0. 0 is equal to negative 1,600 v squared plus 10,240,000, which means this comes over and is divided by 1,600 when it's negative, v squared. So we're going to divide these values and then square root them. Who's got it for me already? 80, is that what it is? Okay. 80, okay, and if we plug it into the bottom, we know 80 squared will give a positive value. Therefore, we can't get a value of 0 on the bottom of this rational function, so 80 works out perfect. Okay, so our values are 0, or our speed values are 0 kilometers an hour, 80 kilometers an hour, and 100 kilometers an hour. So we're looking for fuel efficiency. So we have to plug it into our original function of efficiency with speed. And I haven't memorized the function, so I have to go back up. 16v v squared 640, which is 1,600v v squared plus 6,400, is that? Yeah. Okay, so all we have to do next is plug those values in. So for the very first one, when we plug in a speed of 0, what is our efficiency equal to? 0. So we're using 0 liters per 100 kilometers. Is that what it's measured in? Let's just go double check the top. Fuel efficiency is in liters per 100 kilometers. So it's using 0 liters per 100 kilometers. E at 80. Okay, at 80 is going to be a little more difficult. Let's figure this out. 1600 by 80. I need you guys with calculators to help me out here. 10 as a value? Excellent, thank you. So it's using 10 liters per 100 kilometer. This funny looking thing should be an L, so I'm going to fix that. 10 liters per 100 kilometers. And finally, E at 100. Put the start of it up here. You guys with your lovely calculators help me out. 9.76, excellent. So, according to this vehicle, what is most efficient? Is it? 0. Yeah, it's debatable whether it's legal or not. But if you actually want to be moving in your car, obviously we really don't want to be using this. So this is illogical. We wouldn't use 0. So what is the most efficient between our two speeds here? 100. 100. It's only using 9.4 liters per every 100 kilometers. So this becomes the most efficient speed. So always do 100. Don't do 80 on the highway and slow me down, okay?